Hello everyone. Today I'm going to be talking to you guys about solving logarithmic equations, and by now we know a variety of techniques and laws revolving around logarithmic notation and exponents, and I want to demonstrate our understanding and knowledge of these laws and techniques through solving logarithmic equations. I got a bit of a tough one over here, and then after that we'll get on into an application problem, a real life problem that deals with exponential modeling, and we'll use the techniques and laws we know to solve that application problem. So let's get into this first. It's a bit of a tough one. We got log p plus 5 minus log p plus 1 is equal to 3. Well, I know that we're subtracting over here, and I know that I can use a quotient law. Well, how do I know that? Well, because we have a common base of 10 on both sides of this expression. On this side of the equation, I have two bases of 10 over here. And how do I know that? Well, I know that through convention, when we don't denote the base beside the logarithm, we assume it's base 10. So let's use a quotient law. We got log p plus 5 divided by p plus 1 is equal to 3. How am I going to get rid of the logarithm? I simply treat this part of the equation as an exponent of the base 10. I do the same thing on this side. This essentially is going to cancel out my logarithm that is base 10, and I'm just going to evaluate this side, and this side is going to be 1,000. 10 to the 1 of 3 is 1,000, so we got p plus 5 over p plus 1 is equal to 1,000. And now I'm just going to use basic algebra to isolate for p. We got p plus 5 is equal to 1,000p plus 1,000. I just multiplied both sides by p plus 1. Subtract p from this side, I'm going to get 5 is equal to 999p plus 1,000. Subtract this side by 1,000 and that side by 1,000. I'm going to get negative 9995 is equal to 999p. Divide this side by 999 and this side by 999, and I'm simply going to get negative 995 divided by 999 is equal to p. And we solve this equation using the quotient law. Alright, so now I want to demonstrate our knowledge of logarithmic and exponential laws and techniques to a real-life situation / problem. Over here, let's read the question. We have the population of a town can be modeled by the exponential function p of t is equal to 1006 times 1.016 to the exponent t, where t is the time in years and p of t is the population of the town. Use this model to predict the time it will take for the town's population to reach 20,000. Alright, so what do we know here? We know that the population at this moment is 20,000 at a certain moment. We don't know the time, so we're trying to find the time. So let's simply sub in this into our equation, and we have 20,000 is equal to 1006 bracket 1.016 to the exponent t. Alright, now basic algebra tells me that I can simply divide 1006 from both sides. So over here we'll just get 1, and over here we're going to get, or approximately get, 19.8807 is equal to 1.016t. Now, what do I do here? We're trying to find the exponent. We're trying to find what t is, right? So what I can do is I can use the power law, which tells me that I can just simply shift this t to become a coefficient of the logarithm of 1.016. So let's do that. And whatever we do on one side, we have to do on both sides. So let's take the logarithm of 19.8807 is equal to log. Now I'm just simply going to shift this t over here, and I'm going to get t log 1.016. Basic algebra tells me I can divide both sides by log 1.016, and I'm going to get t. So let's do that. We got log 19.8807 divided by log 1.016 is equal to t. That is going to approximately give me 188.35. So it's going to take me 188.35 years for the population of this town to reach 20,000. And what have we done here? We've demonstrated our knowledge of logarithmic techniques and laws to solve a real-life application problem.